15 set 2 electrical question number 10. It says the circular turn of radius 1 meter revolves at 60 rpm about its diameter aligned with the x-axis as shown in the figure. The value of mu 0 is 4 pi into 10 to the power minus 7, and if a uniform magnetic field intensity H vector which is along the z direction, so z axis, it is 10 to the power 7 is applied, then the peak value of induced voltage is being asked. So you remember one thing, that induced voltage or EMF, it is equal to minus d phi by dt as per Faraday's law. So change in flux with respect to time is the voltage induced, and it will be such that it opposes the change in flux. So this is opposing change in flux. The minus sign indicates that polarity, such that the change in flux can be reduced. Voltage is induced in such a manner so that, for example, current is flowing in such a polarity that the change in flux, if it is reducing, current will flow such that it increases, and if it is increasing, the voltage will be such induced in such a polarity such that it makes it decrease. So flux change is opposed. Now here in the question, this is z axis, this is x axis, so this is minus y axis. You use the right hand thumb rule, that convention should be followed. So x cross y, this is plus y, x cross y is z. Now the ring is like this, and its diameter is along the x axis. Now it is rotating with omega. Now coming to the solution, if the ring is rotating with omega, this is minus y, this is x, this is z, magnetic field is like this, H vector. Now the ring is like this, along the x axis is its diameter. Now see the area vector. How is the area vector in this position? It is in y direction. Now the area vector when the ring turns an angle theta will be like this, right? And this is 90 minus theta, because z and y will make 90 degree. So at any moment area vector will make theta with y or x axis, because you see you can rotate this like this along the xy plane. Such that angle of area vector with z will be 90 minus theta. Now you need to understand this point, that the area vector was first like this along y, minus y. Now when it is rotating like this along the x-axis, keeping its diameter along the x-axis, the area vector will also be rotating. Now what I am trying to tell, this area vector will make an angle theta with the y as well as with the x. So xy plane, with the xy plane it will make an angle theta while it is rotating along, keeping its diameter along the x-axis. So the angle it makes with z, the area vector, at any given time is 90 minus theta. So flux equal to B dot A equal to mu h, which is constant, A, which is area. So this is dot product, so area is pi r square, where r is the diameter of this ring, times the angle between the B, that is along the z axis, and A, area vector, that is 90 minus theta. So cos of the angle between these two vectors. So flux as a function of time can be written as mu h pi r square into sine theta. Now what is theta? Theta equal to omega t. So you can write it mu h pi r square omega t. So theta is a function of time. Right, theta is omega t. Now phi t equal to mu h pi r square sine of theta. So phi t as a function of time can be written as mu h pi r square sine omega t. So voltage induced can be written as minus d phi t dt as per Faraday's law. So this is equal to minus mu h omega pi r square cos of omega t. Now maximum value of induced voltage, that to magnitude, can be written as mu h omega pi r square, because cos omega t maximum value is plus 1. Now coming to the value, mu is 4 pi into 10 to the power minus 7 multiplied by h value is 10 to the power 7 into omega. You need to know that omega is 2 pi n by 60. So 2 into pi into n. N is rpm, rotations per minute. So 60 rpm. So 60, 2 pi n by 60. So omega value is found out. This is h value, this is mu value, multiplied by pi into r value is 1 meter given, so 1 square. Now 10 to the power minus 7, 10 to the power 7 gets cancelled, and 60 and 60 gets cancelled. So it is 8 pi cube. That is the value it is coming, around 248.05 volt. So the answer is 248.05 volt. This is the answer. Thank you.